Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Intel's Panther Lake. So let's dive deep into it. Now this puppy was announced in basically Consumer Electronics Show 2026. So let's understand what the hell is going on. Well, Intel is not doing great recently. Specifically, last 5 years has been rough on Intel, so to say. Basically, they went from dominating to being dominated. When Intel was at their heydays, like let's just say 2015 or something, they were the thing. Like there is Intel and then there is everybody else. Right now, there are two people firing missiles at them. One is ARM. Now, in the early days, nobody was taking ARM seriously because everybody knew while ARM is great for mobile phone, it will not get into desktop, laptops, and servers. Yeah, that is no longer true. So yeah, not only many AI servers are literally ARM based and laptops are becoming ARM based. That took away a big chunk, and then AMD became good. So AMD's Ryzen reconstruction, basically when they're like a clean sheet design they did, it worked. Like ironically, I'm really poorly timed. I bought AMD Bulldozer. If I had waited for one generation or bought Intel at that time, it would have been better, but such is life. So basically, the whole clean sheet design they did with AMD Ryzen and gambling on chiplet design, it paid off. Like it paid off. Like their shares, like basically how much new units they're selling, they slowly started to climb up. Slowly started to climb up. And the server market that was like done sorted. Over time, the Zen core became so good, the Epic lineup became so good that people are like, bro, it does not really make sense. Now again, some companies are still holding on to Intel simply because they have like software validation. At that point in time, of course, they're not gonna risk changing things. Intel is okay enough. So, but again, in new sales volume, it is starting to show. It's like, ooh. And that crossover point happened in 2020 to 2021, whereas like AMD is almost equivalent, if not exceeding what Intel did 2021. So, crossover point happened. So this was a very bad turn of event for a company that was like the daddy. So that was bad. And why is that? Well, they did a lot of debacles. First debacle, hilarious, was 14 nanometer debacle, whereas like 14 nanometer plus, 14 nanometer plus. So that meme became a meme. And be mindful, there are certain cases, again, from investors' point of view and some other players also. So that was an issue, again, not for consumer level, but it was an issue for a business level. And another that was really bad, like that really burnt people off from Intel. And again, that's why you may not be hearing about Intel news for last 2 years, was their 13th and 14th gen Raptor Lake CPUs had an issue. The voltage ring was messed up, either the microcode was messed up, and sometimes turns out there was physical oxidation issue in the actual silicon. And all Intel did is said, F you. So on paper, they were saying, oh, it's like, what we're going to do? FEU. Basically, oh, you lost your CPU? FEU. First, they tried to blame it on motherboard, but again, server people started to notice it's like, bro, our game servers are not working. And given the fact that those are server systems, they are very conservative, very well cooled, and we have telemetry data on that. They're like, yeah. And then it turned out that it was actual issue. Now again, things happen. How do you deal with those things? That defines whether people trust your company or they just say, yeah, this is a last Intel system I'm gonna buy. And how they burnt and pissed on the customers, I would not be shocked that people just lost faith. And if you paid attention to before this AI bubble, that Intel laptops started to first time for very long time actually were genuinely cheaper than AMD systems. AMD was no longer the cheap option. They literally burned off people where it's like, bro, your CPU, lol. So, and this whole thing, oh, we're gonna take care of a customer. What does that mean? FU. So again, it's understandable why this line crossed over. So Panther Lake is a sort of like, revamping, and this is 15th gen. I have no idea. I want to blow them up, whoever is coming up with this sort of weird naming convention. Because again, there was something before this. There was Aero Lake, and somehow that and this is same. But basically, this is a refresh, so to say, of the architecture, not the silicon architecture, the actual electronic architecture that is on mobile-focused SoC. They are not focusing on making CPU alone. They are not focusing on desktop or server-grade hardware. That's not the aim. Aim is making SoC, basically the complete package, this puppy, so to say. And the big selling point is that they're having GPU, a dedicated GPU. Now, we had GPUs because you have to understand that this is long ago. Intel had iGPU, AMD also had something, but AMD, I'm talking before AMD Bulldozer, they always had a good understanding how to integrate actual GPU silicon, not just like, okay, have a video display output. No, what you had iGPU, that was video display output. It was not meant for playing game. It was like just something rather than nothing. So they finally, AMD took a gamble and they started to create APU lineups. It was not a very popular, but it was unique and it had its own niche, so to say. And after that, they created Bulldozer and was like, okay, just remove the iGPU because you're gonna buy a system. But in recent years, as in like last 5 years, people are starting to realize that desktop GPU have become stupid. Meaning every new launch of a GPU, I went from GTX 1070 to RTX 4070, and every GPU announcement is like, we are more efficient, we are more efficient, more efficient. And my power supply went from 100 watt to as in like GPU, to 100 watt to 400 watt. I literally have a connector. New connector was invented just for GPU, so you can dump 600 watt into it. What the hell? But if companies do not want to smoke cocaine, they can actually do is make a good silicon on the same die space as the CPU and have decent performance, like actually competent GPU. And if you're comparing it to old GPUs, it will kick ass. Like that is possible, but nobody had done it seriously. AMD started to do it, and that's why basically Valve handheld became a reality, because they were actually doing it. And this is Intel's like serious attempt to do it. They got things sorted by Arrow Lake. This is time like let us flex. Like AMD did the flexing, got a good device out of it. Cool, awesome, GG. Let us flex. Let us show what we can do. So they are putting Battle Mage graphics unit, and now penalty of that is you do need a lot of RAM, like bonkers amount of RAM or fast RAM. So they do support DDR5, duh, and socketed system, it can go up to 7200, and if you want LPT DDR-X memory, that can go up to 9600, which again, if you want the GPU to flex, you may require that. However, the RAM capacity will go down. It will go down from 128 gigabyte to 96 gigabyte. So that is there. So if you are doing AI and all that, you might want to choose lower SKU. But if you're like high-end gaming, you might want to choose higher frequency. So options, there's a lot of wiggle room here. And how close is the performance? Early reviews, it's actually good enough. And be mindful, many low-end system, and I'm talking not the flagship laptops, I'm talking like most laptops that you buy that has dedicated MGPU, mobile GPU, it can beat it. Like flat out, it can beat those. And again, let that be clear, it's not the fault of MGPU, it's the fault of NVIDIA and laptop partners. NVIDIA just trolls the companies like 4070s, 4070s. Like, no, it's BS. So on paper, you get 4070. In your bank balance, you pay for 4070, but what you get is barely 4030. So that creates a very ugly scenario for customers, where on paper they're like, hey, we have 4070 in this laptop. Neither the thermal envelope is there, neither the actual silicon is good enough, and you get a poo-poo performance. This puppy can beat that. This is just a silicon, one silicon. This puppy is like, bro, I got you. I got you. I can kick ass and take name all day. And that is a very desirable thing. We do not need e-waste. We do not need mobile GPU if it's not done properly. So this is a very amazing thing. And because I'm going to talk about the silicon engineering they did, this time they have more power, which again, you hope so, and they are more efficient. At the same time, let that be okay. It's not like, okay, it's more efficient when it's low power state and it takes power when it's high performing, which was the case for older system. No, this will consume less power while giving you more performance. Like that's the reason why I bought AMD. AMD was AMD for 7000 I have. Flat out, Intel did had some processors that were a bit more powerful, but problem was not only they were expensive for some reason, they were consuming 200 watts of power while AMD was 75. I do not have a advanced cooler. I just have a box cooler on that 12 core system. It's fine. It's like, me good, sir. Me good. Me fine. So this time they're like, no, we are also good. Where we're gonna consume less power and do most work. So let's understand how did they crack this. Well, Intel is now scaling up the next generation of fabrication technology. They are one of the few OG fabrication lab that is still surviving in America, and they are switching the things. They are switching the name. So they are going from nanometers to Armstrong measurement. Now, what is that? 10 Armstrong generally translates to 1 nanometer. Do not ask me why, but it is weird. And 18A, that fab name that they are using, 18A, or process node. It's a 1.8 Armstrong. That generally translates to 1.8 nanometer. Why not just say 1.8 nanometer? Do not ask me. It's most to do with marketing and all that. But they are doing that. Okay, that's just a machine. That's a precision machine. That's your end mill. How small that is. Cool, awesome. What about the actual silicon? Silicon, they are going from FinFET to ribbon FET. Now let that be very clear. It's a name that Intel is using, but that sort of topology, basically having, instead of crisscross like this, having a gate that you are surrounding with dielectric, MBC FET, it's what we call gate all around. It is better with control, and the biggest advantage, it allows you to shrink the silicon, meaning you can actually make more like millions of transistors on a smaller footprint. So that is, again, for mobile SoC, it's a desirable thing. So far, it's a good thing. And again, Google Gate all around, you will find a lot of company, almost all company have something similar to that. Samsung has it. I'm pretty sure all other brands also have it. So NVIDIA also has it. So let that be clear. That's a decent upgrade. It's more of an upgrade like Intel Kasha. However, backside power delivery, this time they surpassed everybody else. So you have to understand this. We know how to make amazing silicon. Then why don't we make it? Well, we can't manufacture it. So many times, like I'm not joking, this actually happened. It's hilarious to me, is that camera sensors, they had silicon, that is the actual photon conversion. Cool, awesome. And your brain will say, put it on front, right? Like photon conversion, and then your wiring. But here's the silicon was always designed in such a way that you take silicon, you do the etching, then you layer it up layer by layer, layer by layer, layer by layer, layer by layer, you keep building it. That was front-side delivery, meaning your actual sensor had wiring on top of it. Not even joking, like that was a big limitation. The sensor was not as bright as it could be because again, there was so much wiring on top of it. Then after recent development in silicon development, they come up with backside illuminated. Finally, like, hey, make sure the sensor is the front and wiring is on the back. Like, why did it took so long? Well, they knew, like everybody, every Tom, Dick and Harry knew. It's just that we could not manufacture it. Somebody cracked how to manufacture it. Tada, every camera sensor is now backside illuminated. Intel did something similar. So it's a quantum leap, technically speaking. So what they realized is that we have transistor, cool, awesome, GG. Now this transistor required two things, signal path and power delivery path. Power delivery path is different. Power delivery has to be big, chungus copper lines. And copper is very resistive. Once you start to make them small, they become very resistive. Ironically, at copper, at like, those sort of nanometer scale, it would be better if you made them out of tungsten, because free mean path of electron is smaller or something like that. Basically, tungsten at those sort of nanoscale transmits more efficiently, some reason. And molybdenum is also one of those things. So they have an issue where it's like, okay, you want big chungus copper, so it can deliver power effectively. Penalty of that is, where is the space? You have copper and you have data signal. Now data wires have to be as tiny, as slim as possible so they can handle high frequency. Cool, awesome. So you have two things. One a big chungus, one you want to be very slim. Now we try to fit it, but once you are reaching a point where it's like billions of these sort of wiring, it's reaching upper limit where it's like, bro, we can't really do much about it. So somebody had the idea, what if we had two-side silicon? As in, you have silicon, you have data on one side and you have power on the other side, because again, they also cause interference to each other. Power has its own sort of signature, radiation, which again, they try to minimize, but you can't eliminate. Especially you can't eliminate if you have a conductor and you have signal wire that is 5 nanometers apart. There is a limit to that. So what if you created two separate wiring? Basically, take the power wiring, that is big chungus copper, put it on the bottom, put the silicon on top, and then have digital wiring on signal wiring on the top. Okay, how do they actually manufacture it? They take the silicon, they etch the whole stuff, cool, awesome. They do the signal wiring, cool, awesome. They take the silicon wafer, twist it, and they grind the hell out of it. And then they layer up the copper power layer. That's how they are basically, that technology of taking the wafer and just going yoink it and then doing stuff on the backside. And I'm confused how the heck they're holding it without destroying it, but somehow they are doing it. And that's how they are achieving the backside for full engineering. So far, that itself is black magic, but then they have extra black magic, which is nano TVS. Because again, that gives you all the wiring area. Okay, you got the copper vias, copper wiring and all that, but how the heck you drill through? Like you have to go through the silicon. How do you do that? In the old designs, it was vias. It worked, but it was not that great. They came up with what they call nano what they call, yeah, nano TVS, through hole vias, and it's too small. And again, my gut feeling is it's not copper, it's way too small for copper. So either it's molybdenum or tungsten or something like that, because they're saying it's much tiny. Now they can pump a power, extract the data, and because these things are separated by silicon as a layer itself, now you have the advantage where the signal can work at much higher frequency, the power can work at much lower interference. Benefit both side goes up, meaning that's the reason why they can reduce the power draw while increasing the performance. Meaning your car, instead of 300 horsepower, it's 400 horsepower, and instead of mileage of 10 kilometer per liter, now it's 20 kilometer per liter, or like what, 50 miles per gallon or something like that. So that is the biggest jump. Be mindful, while gate all around does exist in some way or the another, this backside power delivery, this is the first time. And again, let me be very clear, this is what we call BSI moment. It will change how silicon is made. So it's just like, how the heck they did that? And be mindful, they are operating on it. It's not just like, okay, oh, we flip it and we do laser etching. No. You have to do things into it. You have to grind this. How the heck you're grinding silicon without cracking it? So they did figure it out. Like somebody was like, okay, let Intel shine. Like we gonna flex, and we're gonna flex hard. But I do expect all other fabricator manufacturers would be like, bro, just give us 5 months. We're gonna flex this puppy hard. So this is the technological upgrade. So what about the products they're releasing? Again, I have no idea who came up with the naming convention, and they need to be boomed from the planet Earth for sanity of humanity. But the naming, I'm not joking, this is real. This is the real chart from them, which is Intel Core Ultra X9388H. It's a railway name is smaller than this, man. Oh, by the way, what is the second one? Intel Core Ultra 9X has been removed. 386H. It's like, why? If you remove the X, keep everything else is the same. It's like, it's you only change the one variable, you do not change 2, 3 variables, then it becomes confusing, because now people will like, what if you have X less version which is 388H? There won't be. There is like, remove X and reduce the number 8 to 6. Why? Who came up with this weird naming convention? And again, you have 1, 2, 3, 4, 5, 6. 6 set of units are there. 6 set units. It's like, that's just dumb. That's just bad. Can you remember the old Intel? It was like, Core 2 Duo, the end, go home. That was my first CPU. So, and they have like, Intel Core Ultra X7368H, 366, 365. It's just sad, man. Like, I'm genuinely like 16 core, both have like the 16 core, and one is like 5.1 gigahertz, another is 4.9 gigahertz, and 18. And again, you're like, wait a minute, why they are not increasing frequency? They can, they are choosing not to. The idea is to beat Apple at Apple's game, not to make the next workstation. They can make the workstation, but the idea is to beat Apple, where they're like, no, we are efficient and powerful. They're like, no, we are the same. So, and again, on the base of Dice GPU, yeah, this puppy will flex hard. This is like, bro, don't compete. Like, we got this. We good. And like, Intel Arc B390, Pro B390. So Xe cores, they have 12 Xe cores. And be mindful, we have hundreds of core in our GPUs. It's like, you don't need that. Like, I have no idea what happened. Like, desktop graphics card just went stupid, where it's like, what if we have more? And now they're like, what if we don't want to work? What if we just say, AI render it? It's like, what the hell happened? So that is there. Oh, this puppy works at 5.1 gigahertz. That works at 2.5 gigahertz. And teraflops are huge. It's like 122. Back in the days, that was the full teraflops output of a GPU, desktop GPU. So that's a good number. Again, for dedicated on device, that's like sure to take money. And power envelope, this is another aspect, 25 watts. That is good and tight. And maximum power only goes up to 65 or 80 if you have like really good cooling, meaning they can actually give you decent horsepower while you have a handheld, meaning they're directly firing missile at AMD's Valve offering. So, and this time they have upgraded the offerings. So they have 3 processors. So they have power cores, that is doing the heavy lifting when you have video rendering or some like heavy crunching. Then you have efficient, most of the time these will be loaded. And then you have very low power, which is like something background task which has to work. They're like, okay, put it at very low task, like, clocks and updates and all that stuff. Then you have dedicated NPUs. Why? But again, everybody is AI damaged, so they have it GPU, decent GPU, that's the good part. And power envelope does give hope that you can have Windows laptop that is not cooking you. So it's a good offering. Oh, be mindful. If you are a big consumer, like let's just say Valve itself comes to them, it's like, hey, we want 1 million unit. They can arrange all of this. Meaning they can design in such a way, hey, power cores will be wasted and efficient core is good enough for gaming. What you can do that, like they can tailor it for you, where it's like, okay, you know, remove the power cores, efficient and low power, that will reduce the power envelope even more, and dump all the available power into your GPU. So now your GPU, let's say instead of having 12 cores, maybe 24 cores, so it flex even really hard. So that's the whole point. That chiplet, sub-chiplet design that they have, they can tweak it based on the customer. So if a gaming console, let's say Xbox comes to them or Sony comes to them or in Nintendo, I doubt Nintendo will try to do that, but let's just say they do, they can like, we got you fam. We can tweak exactly how you want it. So there is a good chance this could work really good. So what about the future? Well, early reviews are in, which again, based on this, I'm making it, it's optimistic. Let that be clear. There is a good chance, there is good hope that it could work out. And again, it's early reviews, so take it with a grain of salt, but Wind is optimistic. And we do need competition in PC space. AMD has been slowly creeping up the prices because there is no competition. And again, I blame Intel for this, that how badly they pissed on the customer, especially it's like, oh, your CPU fried yourself because we messed up the quality control. Yef you. So I cannot blame AMD. It's like, if I were AMD, I'll also milk the profit. It's like, profit baby. So they're doing that, and we need competition. We want good competition. Only then we can have quality outputs. So that is there. And finally, I've been watching that the train slowly catching up, like when basically Apple jumped from x86 to ARM for their laptops. That was a big jump. And again, they had full in-house integration, Rosetta and all of that jazz that allowed them to really flex on power to weight ratio. Power to performance ratio. It was good. There was no discussion about it. And that time it was like comparing 3 hours or 4 hours of battery life versus almost 10 to 12 hour battery life. And the gap actually grew. But I've been showing slowly AMD is also making good, and this one is, you can almost see instead of X gap, as in like, oh, it's 2 times or 3 times better, it's like, you know, it's like 10% or 20% gap. That's a very good, that's almost like, you know what, that no longer is a necessity for buying an Apple laptop. That's a good thing. That's a good progress. And again, if you are an Apple user, again, this is good. You want your Apple hardware to be reasonably priced. If they knew they are the only one that can make a good mobile system, as a laptop and all that, they will never reduce the price. And let that be clear, right now the biggest hurdle in battery life, it's not the goddamn laptops or the CPU. It's Windows. Windows is not optimized. So either Linux take care of it or Microsoft finally fixes it, but again, you are more likely to find a unicorn than Microsoft fixing Windows. So that is there. Gap is shrinking. I'm happy with that. And laptop and handhelds are getting great iGPU. That is very awesome. You really do not want to look into what you get for, oh, I'm gonna buy MGPU, mobile GPU, and it's like cost goes up, price goes up, hardware becomes complex, but outcome is poo-poo performance. What if just put one good silicon, the end, go home? That's far more desirable, especially in that mid-range. I'm not talking about flagship where you're like, money is no object, but most people are not in that place where money is no object. So that is there. It's like really better than mobile GPU disappointment. Like most of you who had dealt with this know this. So, and again, we really desperately need low-cost compute. The AI brain damage is way too serious, way too much money is being burnt, and it's almost like I can sense fear in them. It's like, again, even Intel's own keynote is like, for our investor, for AI and all that, it's like, why are you so scared? It's almost like they know that it's a bubble. Like, you can't charge $500 billion for something, because again, nobody can afford it. US Army can't afford the hypersonics. They can't afford B2s. Their early contract was like hundreds of B2, and they got the bill. It's like, yeah. No, if they can't afford it, trust me, there is nothing AI data center of those stupid cost can do. Like nothing. You can't generate profit of that. It's like, so this affordable home at New York, what is the price? $7 trillion. It's like, yeah, no. So we really need low cost devices. And again, you can even see the chiplet design, like how they are slicing it. So this was my presentation on basically Intel's new Panther Lake offering. I hope it works out well. CES 2026. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.